Hello, and today we are doing 7th grade math, chapter 4, lesson 2. We are comparing and ordering rational numbers. Now, we need to cover what is a rational number, what is a common denominator, and what is a least common denominator. A rational number is any number that can be expressed as a ratio in fraction form. It includes whole numbers, integers, decimals, terminating, and repeating. In English, it's any number that can be written as basically a decimal, a fraction, a percentage. Those are rational numbers. So examples would be negative 0.8, 20%, 2.2 with a bar notation over the 2, 1 half, negative 1, 1.4444, negative 1 again for some reason. Those are all rational numbers. Common denominator. A common multiple of 2 or more numbers. So an example here would be 1/8 compared to 3/4. We would want the denominator to be the same to have a common denominator. So if I were to take, let me go ahead and use this as an example. We'll erase that for now. That we'll come back to that one. I have 1/8 and 3/4. In order for me to figure out which one of these two is bigger, I need to have the same denominator in order to compare the two. For example, 3/4 can be turned into a denominator of 8 if I multiply both numbers by 2. That will become 6 over 8. 3 times 2 is 6. 4 times 2 is 8. So what is bigger, 1/8 or 6/8? 6/8 is definitely bigger. Therefore, 6/8, which was originally 3/4, is bigger than 1/8. And that's why we use common denominators to be able to, in order to compare fractions. Least common denominator is what is the smallest denominator that they can have together. Another way of saying this is possibly the least common multiple of the two. And there's the example that I just erased, and now I kind of regret doing it. But let's go ahead and redo this. So a least common denominator would be something like, we'll come back to these, like this. 7/12 over 8/18. So I've got 7/12 and 8/18 that we're comparing. Now, I can't compare them because one denominator is 12, one denominator is 8. They're not the same number. Maybe I can divide both to go down to something because both have a factor of 2. The problem is I can't divide this one by 2 because 7 will not be divided by 2 evenly. Therefore, I'm stuck. The only thing I can do now is to get them to become bigger and upscale. The way I do that is I find multiples of both denominators. So I have 12 and 18 respectively. I'm going to count by 12s. 12, 24, 36, 48, 60, and so on. I don't know my multiples of 18 right off the bat, so I'm going to use my calculator on my phone to do this. So we have 18, and then 18 times 2 would be 36. 18 times 3 would be 54. 18 times 4 would be 72. 18 times 5 is 90. And if we look closely, we already have a common multiple between the two, and that is 36. Now, in order to get 12 to become 36, we multiply it by 3, because we see that's times 1, times 2, times 3. So what I'm going to do is multiply these both by 3 to get a new fraction. My 12 will become 36, but 7 times 3 will become 21. So 7/12 becomes 21 over 36. Down here, to get 18 to become 36, I multiplied it by 2. So I'll multiply both of these by 2. I'll erase this. 18 will become 36, and then 8 times 2 will become 16. Therefore, 7/12 is bigger than 8/18 because 7/12 is 21 over 36, while 8/18 is 16 over 36, which means I will write it like this. That 8 is bugging me. 7/12, that 8 doesn't, yeah, whatever. It didn't get any better. 7/12 is greater than 8/18. Now, going back to this, what the goal of this chapter is to compare rational numbers. Again, comparing rational numbers means we are trying to figure out which one's bigger, which one's smaller. Maybe we're ordering them from least to greatest or greatest to least. They want us to compare -1 and 5/6 to -1 and 1/6. Now, there are a few steps here before we just jump in and go, this one's bigger. So, let's talk about it. -1. Ooh, made 1 a fraction. -1 and 5/6 compared to -1 and 1/6, if I got this correct. Yes. We are going to need to look at the symbols first. They are both negative, which is going to be a game changer. So bear with me. Some of us may already know the answer, but let's walk this through. The next thing we need to look at is going to look at the whole number. They're both the same, so neither one is bigger so far. Notice that I checked, sorry, I need to backtrack here. I checked the symbols. If one is negative and one is positive, the positive one is automatically bigger. Hands down, easiest way to do that. Since both of these are negative, they're both equal as of right now. The whole number is both 1, therefore they're both equal right now. Now, as we just learned, we need the common denominator to be able to compare fractions. But we have a common denominator. They're both 6. Therefore, we're going to look at the numerator to tell us which one's bigger. I have 5/6 and 1/6. Now, right off the bat, you're thinking, well, the 5/6 is bigger. 5 is bigger than 1. However, they are both negative. If these were positive, 1 and 5/6 would completely be bigger than 1 and 1/6. But they are not both positive. They are both negative numbers. Therefore, with negative numbers, it's the opposite. Would you rather owe somebody $5 or would you rather owe somebody $1? Therefore, -1 and 1/6 is bigger because it is closer to 0. It is -1 versus -5. On a number line here, it's indicated that -1 and 1/6 is right here to the right of the line, near -1, which is near 0, whereas -1 and 5/6 is further down here, closer to -2, which would make this one a smaller number. Remember, the more towards the left, the smaller the number is. The more towards the right on a number line, the bigger the number is. Our example here is utilizing -5 and 5/9, comparing it to -5 and 1/9. Same idea here, both are negative, both have a whole number of 5, both have a denominator of 9. 5 and 1 is what we're comparing, just like last time. -5 and 1/9 would be somewhere close to here, whereas -5 and 5/9 would be somewhere closer to here. Again, would you rather owe somebody $1 or owe somebody $5? Therefore, -5 and 5/9 is smaller than -1 and 5/9. All right, so we've already compared these. Let's do some of these got it's, and then we're going to talk about ordering rational numbers. So, we have 5/6 compared to 7/9. 5/6 compared to 7/9. Now, 6 and 9 both have a a factor of 3. So if I wanted to divide both of these by 3, I maybe could make it smaller. Problem is 5 can't be divided by 3 and 7 can't be divided by 3. So we are not simplifying here. We are instead going to start counting up. So 6, 12, 18, 24, 36. No, I jumped. 30, 36. And then 9 would be 9, 18. So we already have a common multiple. 18 is our common multiple. To get 6 to become 18, we needed to multiply by 3. So both of these are going to be multiplied by 3, whereas 9 to 18 we multiply by 2. So both of these are going to be multiplied by 2. 3 times 5 will be 15. 6 times 3 will be 18. So 5 6 is the same thing as saying 15 eighteenths. Over here, 7 times 2 will be 14. 9 times 2 will be 18. This will be 14 eighteenths. Now, since 15 is bigger than 14, and they're not negative, 5 6 is bigger than 7 ninths. Example C, 1/5 compared to 7 fiftieths. Notice they are both positive, so that's the very first thing we need to identify. 1/5 over, I believe it was 7 fiftieths. Now, I can't divide that 50 to make it any smaller because 7 is a prime number and 7 is going to be a problem. 7 does not have any factors except for 1 in itself. Therefore, I need to convert 5 up to 50. The easy way to make 5 be 50 is by multiplying by 10. And anytime you do that, you just annex a 0. I also have to multiply 1 by 10, which will make it 10. So 1/5 becomes 10 fiftieths, and since 10 over 50 is bigger than 7 over 50, 1/5 is greater than 7 fiftieths. D, negative 9 sixteenths or negative 7 tenths. So we have negatives here. Negative 9 over 16 or negative 7 over 10. I cannot make 9 sixteenths have a common denominator of 10. I could divide these both, except for 3 does not go into 16, so that's not going to work. So there's no making this any smaller. Notice they are both negative, so that's going to be a game changer there. If one was positive and one was negative, automatically it'd go to positive is bigger. Both are negative, so we are now going to need to convert these fractions up. Now, 16, I don't know my multiples of 16, so we're going to count by 16. And we're going to count to something that ends in 0, because 10 is just going to be 10, 20, 30, 40, 50, 60, and so on. So let's wait to see what 16 will be. So I know I have 16, 32, 48, 64, and 80. So we reach something that is a multiple of 10, which is 80. This was 1, 2, 3, 4, and 5. So in order to change this to a denominator of 80, I need to multiply both of these by 5. 9 times 5 is 45, so this will become 45 over 80. Compared to, these will both need to be multiplied by 8, because 8 times 10 is 80. And 7 times 8 will be 56. Therefore, 7 tenths becomes 56 over 80. 9 sixteenths becomes 45 over 80. However, they are both negative. So again, would you rather owe $45 or owe $56? Remember, when they're both negative, it's the smaller of the two that will be the bigger number. So therefore, negative 9 sixteenths is greater than negative 7 tenths. All right, now we're going to be talking about ordering. Ordering means depending on what they want us to do, they are going to order from least to greatest, greatest to least, whatever. Now they want us to order the set 3.44 pi, which is a symbol that means 3.14 15926, and so on and so on. And 3.44444 forever. Okay, so let's go ahead and order these from least to greatest. Now, when you're looking at least to greatest, we're going to look at it if any are negative, because negative numbers are going to be smaller. They're all positive. 3.44, pi, 3.14, and 3.4 forever. Now, we're going to line up the decimal points and compare using place values. So, we have 3.44. 3.44. We have pi, which is 3.1415. So we're going to put 3.14. And I'm actually going to put the rest of it here. So it's 159. We'll just write 15926. That means I'm going to need to annex zeros here to it in order to compare place values if anything else comes about. So again, this is that pi symbol. Now I need to write 3.14 with a bunch of place value zeros. And my last one is 3.4444 repeating, which is the same thing as saying 3.444444. Now, they are all positive. Now we're going to go from least to greatest. All are 3, so that doesn't help us. Now we look at the other numbers. This is a 4 and this is a 4, so they're going to be the two bigger numbers. We're going to be looking at these two that have 1s. We look at the next place value, 4s. They both have 4. This one has a 1 and this one has a 0. So this one is automatically our smallest number. So from least to greatest, we have 3.14. Then we're going to have this one, 3.1415, which was written as pi. So pi is next. Now we're going to look at the other two. I'm going to do a different color for this one. So we have 3 in both. We have 4 as the next place value in both. We had 4 in the next place value as both. Now we have a 0 here, but this one's a 4. Therefore, this is the bigger number. So the next one would be 3.44. Oh, sorry. Let's keep it in the same color. 3.44. And then 3.4 repeating. And this would be our order from least to greatest. 3.14, pi, 3.44, and 3.4 repeating. And that is exactly what we got. So this is how you can kind of compare them. The reason why we're comparing and we're ordering them is because this is going to have to deal with data sets that we're going to be utilizing later. Math is all over the world. It has to deal with numbers, and numbers pretty much rule everything. So let's do this got it, and we'll call this one a lesson because we're already in the 18th minute here. So let's go ahead and erase all of this. And I know that pi symbol ended up somewhere over there somewhere. Let's see. There it is. Alrighty, let's get to this. We're going to order this set from least to greatest. And it's very important that you always check what the directions are, because it could say greatest to least, it could say least to greatest. So this one we're going to go from the smallest one to the largest one. So we have 23%. We have 0.21. We have 1/4. And we have 1/5. Oh my goodness, I'm all over the place. 1/5. That is our recording of lesson 1. So, all right. So we are going to compare all of these. Now, the best way to compare all these is to keep them as decimals. Keeping them as decimals is going to be easy. So this is still going to just be 0.21. Working with the 23%, any percentages is out of 100. So that's same thing as saying 23 over 100. Again, 23 hundredths is going to be 23 in the hundredth spot. So we can write that as 0.23. So already checking these two alone, this one's bigger. So let's keep that in mind. So we converted that. Now 1/4 is one of those that we talked about earlier that you should have down. You should have that down patch. 1/4, 1 out of 4 being a quarter, it's 25. It is 0.25. If you need a refresher, 4 does not go into 1, 0, decimal. 4 goes into 10 twice, that is 8. When you subtract, we get 2 left over. 4 cannot go into 2, annex is 0. 4 goes into 25 times. Therefore, it's 0.25. So 1/4 is 0.25. So we'll write that as 0.25. Now we're going to go ahead and solve for the 1/5 the same way. Now 1/5 is not necessarily one of those fractions you should know by heart, but it wouldn't hurt keeping these in your notes. So again, like we did last lesson, 1/2 is the same thing as saying 0.5. 1/4, 0.25. 1/3 is 0.3, repeating. 3/4, 0.75. Now 1/5 is going to be one of these you want to add into your notes. We're going to do 1 divided by 5. 5 will not go into 1. Decimal, 0. 5 goes into 10 twice. And that's it. So 1/5 will be the same thing as saying 0.2. Now, all of these have 2 place values though, so I'm going to go ahead and throw a 0 in there so I can compare. Now, since we are doing least to greatest, I'm going to go back and double check that that is my answer from least to greatest. I'm going to look and see which one of these is lower. We're comparing 23, 21, 25, and 20 because all of these are 0. They're all positives, so we can cut those off. So the lowest one is the 20, or this one. Therefore, from least to greatest, we're going to go ahead and move this board over a little bit. From least to greatest, it'll be 1/5. The next smallest one will be the 21, or the 0.21 as it was originally. Then we're going to have the 23, which was a 23%. And our biggest one will be the 1/4, the 25. So from least to greatest, it'll be 1/5, 0.21, 23%, and 1/4. And that is how you order from least to greatest these rational numbers. Any questions, comments, concerns, as always, you guys know how to reach me if you're in my class. Not in my class, leave a comment down below and I will get back to you as soon as I can. And if I don't, feel free to just spam the comments again and go, hey, you didn't answer me, I need help. If you're in my class, don't leave comments. Don't leave comments. Just ask me on Teams, ask me on email. As always, I am Mr. P. I will catch you guys on the next one.